Welcome to the deep dive. Today, we're getting right into the nuts and bolts of language itself, like the deep structure inside words. And we're looking at this from two angles, really. How linguists have traditionally thought about it and how computer scientists tackle it for AI.
Exactly. It's a fascinating comparison.
So our plan is to start with those classical ideas, lexeme and morpheme. Then we'll jump over to the computer side, lemma and stem, concepts that are, well, vital for how machines process language.
And hopefully connect those dots.
Right. By the end, you should have this really solid foundation. It actually helps understand everything from, learning a new language to how that chatbot you talk to works. Should be some real aha moments. Okay, so let's unpack the first part. Classical linguistics. When linguists talk about the inner structure of words, what are these fundamental units they mean?
Good place to start. The first big one is the lexeme. You can think of it as an abstract fundamental unit of vocabulary. It's kind of the main thing lexicologists, the people who study vocabulary itself, look at.
Abstract.
Yeah.
Okay. So not the word itself.
Not quite. Its main job is what they call the nominative function, basically, naming things. But the key is a lexema represents the core, meaning abstractly, covering all the different forms a word can take.
Ah, I think I get it. Like different variations of the same core idea.
Exactly. So take English run. The words run, runs, running, ran. They're all different forms, different word forms, but they all point back to that one abstract lexeme, R-U-N.
Okay.
And it's even clearer in languages with lots of grammar endings, like Russian. You might have huka for hand, rukoi for by hand, ruko for hand as an object. Different forms, but they all belong to the single lexeme for hand.
Mm-hmm.
Shows that abstract nature, It exists on its own level, the lexical level.
Right, the blueprint idea. Okay, so that's the lexeme, the abstract concept. What's the next layer down? Where do morphemes fit into this picture? Are they like building blocks for the lexema?
That's a great question. Because the relationship is, well, it's debated, actually. But first, what is a morpheme? It's defined as an elementary, indivisible unit that carries meaning. It's the core unit of morphology, which is the study of how words are structured.
Indivisible and meaning-bearing. Okay.
Yeah, sometimes called minimal naming units. Think of basic roots, like vodavodsver for water in Russian, or maybe in structure, construct, instruct in English. These carry a core piece of meaning.
Gotcha.
One source used a really helpful Lego analogy. Imagine the finished Lego model is the word you see. The morphemes are the individual bricks used to build it. Each brick has a shape, a form, and a function, its meaning.
Okay, I like that. Makes it tangible.
And morphology, then, is like the instruction manual. It tells you how to combine these bricks, these morphemes, to make words that make sense.
The Lego analogy is great, but it does make me wonder if morphemes are these indivisible bricks, does that mean a lexeme is just built out of morphemes, like stacked together?
You've hit on the tricky part. That Lego analogy helps visualize. But it's also where some linguistic schools of thought really diverge.
It sounds logical, right? Build the word from morphemes.
Yeah, seems intuitive.
But in certain linguistic frameworks, saying a lexeme consists of morphemes is actually seen as, and I quote from a source, obviously incorrect.
Really? Incorrect. Why?
It seems counterintuitive, I know, but the reasoning is about keeping language levels strictly separate. In this view, lexemes belong to the lexical level, the vocabulary level. Morphemes belong to the morphological level, the word structure level.
Different layers of analysis.
Exactly. So morphemes don't make up the lexeme from the ground up. Instead, they operate on or modify the lexeme. They add grammatical info, like s for plural, or ding for continuous tense, or maybe change the meaning slightly with a prefix like un.
Ah, so they interact with the lexeme rather than forming it. Precisely. It's about the relationship between these distinct levels. Though I should mention, there are concepts like lexemorpheme that try to bridge this very gap, looking at both semantic and morphological structure together. It's complex.
Definitely sounds complex. Okay, so we have these linguistic theories, these abstract units. Now, how does this translate to the world of computers and AI? How do machines actually, use these ideas or things like them? This is where it gets really interesting for NLP, right?
Absolutely. This is the bridge to natural language processing. In NLP, we need practical operational ways to handle word variations. The first key concept is lemmatization, and the result is called a lemma.
Lemmatization. Okay.
Lemmatization is a process. It reduces different forms of a word down to its base or dictionary form, the lemma. And importantly, it's usually context-aware and grammatically informed. The aim is to get a valid, meaningful dictionary word.
So it's smart about it. It knows grammar.
Generally, yes. For example, think about the verb to be. Lemmatization would take am, is, are, was, were, been, being, all of those, and reduce them to the single lemma be. Or run, runs, running, they'd all become the lemma run. To do this, it often needs to figure out the word's part of speech. Is it a verb, a noun? And it relies on big dictionaries or lexical databases like WordNet to find that correct base form.
So it's quite sophisticated, trying to preserve the actual meaning.
It is. It's considered a more accurate morphological technique compared to the alternative.
Which brings us to stemming, right?
Yeah.
And the stem, how is that different? Why have both?
Right. Stemming is also a process to reduce words to a base form, the stem, but it's much simpler, often cruder. It typically uses rule-based algorithms heuristics. Think of it like just chopping off common endings based on a list of rules.
Chopping off endings like ing or x.
Exactly, like automatically removing ing or x or eggs. But here's the crucial difference. The resulting stem might not be a real word. Yeah. The classic example is the word happiness. Stemming might just chop off the edaconus and leave you with happy, which isn't a word.
Happy, right. Not in my dictionary.
Definitely not.
Uh-huh.
So stemming is fast. It's computationally cheap. That's its advantage. Speed over perfect linguistic accuracy. Algorithms like the Porter stemmer or the snowball stemmer are common examples. Porter, especially, is known for being quite aggressive in its chopping.
Okay, so lemmatization is careful, aiming for a real dictionary word, the lemma. Stemming is fast and rough, giving you a stem that might just be a fragment, like happy.
You've got it.
So let's explicitly connect these back. How does the linguistic lexeme relate to the NLP lemma? And how does the morpheme relate to the stem? Is it a direct translation?
Good question. Between lexeme and lemma, there's a very strong conceptual link. The lexeme is that abstract idea of the core meaning. The lemma is its practical, concrete stand-in for NLP, the standard dictionary form. Lemmatization is basically the process of trying to find the lemma that represents the underlying lexeme of a given word form.
So the lemma is like the computer's best guess at the lexeme.
That's a great way to put it. It's the operational representation. Now, comparing morpheme and stem, the connection is much looser, much more divergent.
How so?
Well, remember, morphemes are fundamentally meaning-bearing units. Stems, produced by stemming algorithms, are often just algorithmically generated substrings. They don't have a guarantee of carrying coherent meaning, like happy.
Right. Happy doesn't mean much on its own.
Exactly. Now, both lemmatization and stemming work by dealing with affixes, prefixes, and suffixes, which are types of morphemes. They both recognize and either transform or remove them, but their goals are different.
Okay.
Lemmatization tries to get back to a meaningful root, a valid lemma, by understanding the morphemes involved. Stemming just mechanically cuts off parts based on rules without necessarily caring if the remaining stem is a linguistically correct morpheme or word.
So one respects the linguistic structure more, the other prioritizes mechanical reduction.
Precisely. Let's revisit that tree analogy from the sources. The abstract idea of tree is the lexeme. The meaningful parts, root, trunk, branches, those are like morphemes. Lemmatization is like carefully pruning the tree back to its ideal shape. That's the lemma, still clearly a tree.
Okay. Makes sense.
Stemming, well, that's more like taking a chainsaw and roughly chopping the tree down into a basic block of wood, the stem. It's still wood, it serves a purpose maybe, but it might not resemble a tree anymore.
That really clarifies the difference in approach. Okay, so we understand the what and the how. Why does this actually matter? For someone building, say, a search tool or maybe a translation app or just anyone curious about AI, what are the practical consequences of choosing lemmatization versus stemming? Precision versus speed sounds like the core trade-off.
It absolutely is. And the consequences are significant for how well these systems work. Think about lemmas. Because they are real words, semantically grounded and context-sensitive, they're preferred when precision is key.
Like what kind of applications?
High-stakes stuff. Machine translation, where you need the right word meaning. Sophisticated question-answering systems. Sentiment analysis, where understanding subtle nuances is important. The downside, it's slower, needs more computing power, and relies on those big dictionaries.
Got it. Precision costs resources.
Right. Now, stems. They can be grammatically weird or meaningless, like happy, but they're fast and great for simply grouping related words together. Think early search engines or basic information retrieval. The main goal there was often just to make sure running, runner, rant, all got treated similarly to run quickly. Reducing variations was more important than perfect meaning.
So speed and rough grouping are the benefits there.
Exactly. The downside is you might lose important meaning differences or group unrelated words if the stemming is too aggressive, what's called overstemming.
Overstemming, like stemming university and universe to the same stem.
Potentially, yes,
Okay.
depending on the algorithm. Or a classic example is stemming news down to new. You lose the specific meaning. The opposite can happen too. Understemming, where related words don't get reduced to the same stem, like maybe knavish and knave staying separate.
Hmm. So it's definitely a trade-off with potential pitfalls. Does the language itself change how useful these are, like English versus, say, German or Turkish?
Hugely important point, yes. The morphological complexity of the language matters a lot. For highly inflected languages, German, Russian, Turkish, Finnish, where one basic concept, one lexeme, can have dozens, even hundreds of different word forms.
Wow, hundreds.
Oh, yes. Think of verb conjugations, noun cases, possessives, all stacking up. For those languages, reducing these forms via lemmatization, or stemming, is almost essential for effective NLP. Otherwise, the computer treats each form as a totally separate word.
You drown in variation.
Exactly. For languages like English, which are more analytic and have fewer word endings, the impact is less dramatic, but still often beneficial.
And I imagine this isn't perfectly solved for all languages either.
Not at all. Most development is focused on English and major European languages. Languages like Arabic, with its complex root and pattern morphology and variations in writing, present huge challenges. Getting a consistent base word is really tough. So these techniques have limitations and ongoing research areas.
Fascinating. So we've really journeyed from abstract linguistic theory, the lexeme and morpheme, to the practical tools of NLP, the lemma and stem, and why choosing between them matters. Quite the deep dive.
Indeed. And I think the core takeaway is clear. Lexeme and morpheme are these theoretical linguistic ideas. Lemma and stem are their operational cousins in NLP, designed to simplify language for machines. Lemma tries to be a faithful, meaningful representation of the lexeme.
While stem is more of a rough and ready approximation.
Exactly. A cruder tool, often prioritizing efficiency. And understanding this link, this history, is really vital for anyone building or using NLP tools. Knowing the linguistic foundation helps you choose the right tool and understand its inherent limitations. Classical linguistics really isn't just history. It informs modern practice.
That makes perfect sense. Okay, time for our final thought for you, our listener, to chew on.
Right. So as AI, particularly these big neural networks and transformer models, gets more powerful, something interesting is happening. These models seem to be learning about morphology and semantics implicitly, just from the vast amounts of text they process.
Without needing explicit lemmatization or stemming first?
In some cases, yes. It might seem like these older pre-processing steps are becoming less critical because the model figures it out internally. However, does that mean the underlying concepts, lexeme, morpheme, become irrelevant?
Good question.
I'd argue the opposite. Even if the model learns implicitly, understanding these fundamental linguistic units remains crucial. Not just to grasp how the AI is working under the hood, but to critically evaluate what it can really do, where its weaknesses might lie, and how it might fail. So, the provocative thought is this. As AI gets smarter, does our need for a deep fundamental understanding of language actually become more important, not less, if we truly want to master and innovate with these powerful tools?